Anin bonjour, Carl Klimah, Indigenous, Mizizai Igning, Shanabe, Indananoki, Minowa, Ni Gigigud, Ojibwe Moen. Hi, my name is Carl Klimah, and I work for the Mille Lacs Band of Ojibwe. I do speak the Ojibwe language. I will keep the introduction brief, but today we're going to be talking about the seasonal habitat, temperature, and depth of adult and juvenile Ogaa, aka Walleye, in Mille Lacs Lake. And this study was initiated through a tribal fish and wildlife grant, wildlife service. And then we'll have questions at the end. Hold on. Okay, there's the intro slide. Moving on down. All right. This study was completed on Mille Lacs Lake, a big, shallow glacial lake located in central Minnesota. It is roughly 134,000 acres and has a maximum depth of 43 feet. In recent years, there have been limited angling opportunities due to low Ogaa numbers, which has led to shutdowns. Mille Lacs also contains many invasive species, including spiny water fleas and zebra mussels, which have altered the zooplankton community. As a result, the lake has undergone abiotic changes, which include an increase in water clarity and a suspected increase in water temperature. Due to abiotic changes, we believe that there's limited cool water and shade during certain times of the year, particularly the hottest months. So we hypothesized that this limited cool water and shade during the hottest months condenses fish into smaller areas, which we call the squeeze. The below diagram is a depth profile of Mille Lacs Lake before abiotic changes started to occur. The top of the box is the surface of the lake, and the bottom box is the bottom. Depth is in meters on the y-axis. In the past, we believe there was plenty of optimal Ogaa thermal habitat, water which is around 68 degrees Fahrenheit during the hottest months of the year, which allowed fish to spread out. Now this is a diagram of the present day. Due to abiotic changes, there is now much less optimal Ogaa thermal habitat, mainly near the bottom. This could be causing adults and juveniles to come into closer proximity to one another and may result in elevated juvenile cannibalism, which has been shown to be one of the major factors in the Mille Lacs Lake Ogaa decline. So to gain more insight into this theory, our objectives for this study were to assess the thermal niche of juvenile and adult Ogaa across seasons, identify aquatic habitats that are key for adult and juvenile life stages, and identify temporal, spatial, and thermal overlap of juvenile and adult Ogaa habitats. To accomplish these objectives, we undertook an acoustic telemetry study. To gather data from tagged fish, we deployed 61 VR2W VEMCO receivers. The receivers were attached to a PVC pipe moored to a heavy anchor attached to a smaller anchor with steel cable and rope. Receivers were retrieved by dragging a heavy anchor or hook behind the boat and snagging the cable and rope. And all receivers were placed at depths greater than 10 feet to ensure boater safety. Extensive receiver range testing was completed prior to starting the study, and it was determined that the fish detection range was around 800 meters. What that means is as a fish comes within that 800-meter range, we are confident, based on an established level, such as 80 to 90% chance, we are going to receive that fish. And so we are trying for range testing to see how far basically we can hear a fish from our receiver, because everything's influenced from habitat. If it's rocky, it could block the signals between the tagged fish and the receiver, or if it's a cloudy or it's a wavy day, it could jumble up the signal. So what we really need to do is find an average fish detection range so we know how far apart to space the receivers. So we spaced them based on that receiver range testing. We decided to space them 3,000 meters apart in a grid. The map on the right is Mille Lacs Lake, and the receivers are the black dots. The fish detection ranges are the tan circles around the receivers. And once again, the receivers are the fish listening devices. They're listening for the fish tags. We deployed the receivers between June 13th to the 20th of 2018. We retrieved the receivers May 7th to the 20th of 2019. And data was downloaded after receivers were retrieved. To collect Ogaa for the study, we electroshocked from all over the lake. Tagging was completed in under 5 minutes on our electrofishing boat with a TENS machine, surgical sutures, and a surgery cooler. Fish were quickly released to reduce post-surgery stress and mortality. For this experiment, we tagged 70 adult Ogaa between 18 and 28 inches. These were tagged with V13 TP tags, which are capable of measuring temperature and pressure. This is the V13 here. So basically, when these tags are inside the fish, it'll send a little signal out relaying the temperature it's at and the depth it's at to our receivers. We also tagged 35 juvenile Ogaa between 7 and 11 inches with V7 TP tags. These are a smaller version of the V13. The V13 tag can last about 2 to 3 years, where these V7 TPs only last around 240 days. Because these V7 tags only last 240 days or around there, we tagged half of the juveniles in the fall and half at a later time. So we'll get to that in a second. But half the adults were tagged in July of 2018, and the other half were tagged in September 2018. And all of the juvenile Ogaa were tagged in September 2018. All righty, we also deployed, this is an added bonus to this talk, we also deployed 20 Hobo Loggers. Hobo Loggers, you can see on the right here, they are capable of measuring temperature and light readings every 11 minutes for a whole year. So we deployed those. We have 20 inshore loggers in 4 different habitat types. They are placed at 2, 4, 8, and 10 feet, both on the north, west, south, and east side of the lake. We also have 2 PVC trees. Basically, these are Hobo Loggers every 5 feet on buoys from 10 to 35 feet. There's one on the north deep hole and one on the south deep hole. So we can see how the water temperature changes across the column. We each have a Hobo Logger on 61 of each of our receivers. The photo on the right shows this. Recent data files, 47, 17, 10 right here. Those are all receiver Hobo Loggers that were attached. And we also have 13 river receiver loggers attached to 13 receivers that we have placed in the rivers around Mille Lacs Lake. Once the data was downloaded from the receivers, we filtered out false detections using GLaDOS package in RStudio. Dead fish were identified and removed using an hibiscus plot, basically where the fish is at, what station. This is a hibiscus plot. Station number is on the y-axis. X-axis is date. And I put this on here. As you can see, this is kind of like a live fish here. For the first 2 months, it's going around, swimming around to all the different receivers, but then it kind of stops here. And so we would have to look at this to determine, it's not really a dead fish, but it's meaning a dead fish is it's no longer in the study, whether it's left, whether it's truly is dead or gotten eaten. I just say dead fish to reiterate that. But we remove them out of the set using this kind of a plot, this hibiscus plot, temperature and depth plots by date. We used our data only from July 10th 2018 to May 15th, 2019. But we only compared data between September 2018 to May 15th, 2019, as this is the time period in which we had both juvenile and adult Ogaa detections. We used an ANOVA to compare fish temperature and depth by month, life stage, and time of day. Interactions were added into the model, and a Tukey test was performed. Normality was verified with histograms and QQ plots of residuals. And we used an alpha value of 0.05 to determine significance. To determine if both life stages were overlapping, we compared geographic, temperature, and depth data. The two maps on the right are detection bubble plots by life stage, which show the number of unique fish detected at each receiver. To determine if geographic overlap is occurring, both life stages need darker bubbles in the same area. For example, the northeast side of Mille Lacs Lake has darker bubbles for both adults and juvenile Ogaa. We also made box plots of temperature and depth for both life stages. The box plot below is a temperature box plot and shows that both juveniles and adults are at the same temperature. Box plot dark horizontal black lines right here represent the median for both temperature and depth data. And night and day was partitioned to look for further overlaps. On to the results. The adult Ogaa had a survival rate of 68% in this experiment. That is the percentage that survived from the time of tagging to the time of receiver extraction. The juvenile Ogaa had a survival rate of 37%. Both life stages tag mortality rate was between 5 to 12%. That died most likely from ear surgery or tags. And there was heavy juvenile Ogaa mortality in November. Here is a graph of temperature by date for adults and juvenile Ogaa. Temperature is in Celsius on the y-axis, month is on the x-axis. Mean adult temperature is in the red line, while the blue line is for juveniles. From this graph, we see that from October to December, there is difference in temperatures occupied by life stage, but the difference is not as great as it is from mid-January to May. Here is a graph of depth by dates for adult and juvenile Ogaa. Depth is in meters on the y-axis, and month is on the x-axis. Adult and juvenile depths are very different by month. It appears though that from mid-November to mid-January, adult and Ogaa depths become closer to one another. And basically this shading around here is not the 95% confidence interval. I actually have that on our slide I could share after, but there basically is a lot of overlap between that November and that December month between the depths of the two life stages. All righty, here are the box plots by temperature for each month. Adults are in red while juveniles are in blue, and black stars indicate significance difference, statistical significance. The box plots show that the temperature overlap between life stages is occurring in October, November, December, and May. In September, juveniles are in significantly cooler water than adults. But from January to April, juveniles are in significantly warmer water than adults. Here are the box plots by depth for each month. The box plots of depth show us that the juvenile Ogaa were significantly deeper in every month that we compared. So very little depth agreements here. Now, after we partitioned it out for night and day detections, which we still have to work on a little bit, for night and day fish temperatures, there were no significant differences. Although here is a box plot of juveniles and adults day and nighttime temperatures in January. While the nighttime temperatures do not overlap to the point where they are not significantly different, it does appear that more juveniles move into the Ogaa's adult Oga's thermal range as evidenced by the box plot extending downward for the juveniles at night. So during the day, they're up nice and high here, but then some kind of come more into the adults range here at night. And then that shows the temperature too. So this one was depth. You can kind of see that range, the depth there. And then this is the temperature one. So that last one was the depth. And then this temperature one, you can see on the right here, the juvenile starting to come into range of the adults. Because of the potential for January having overlap in temperature and depth, we compared the geographic position of adults and juveniles during this time. From the maps, we determined that there is the potential for overlap between life stages on the east side of Mille Lacs Lake. Alrighty, so now this slide here is a little bonus of one of our Aiken PVC trees. And I just wanted to show everybody what Mille Lacs Lake is looking like at different depths. So this one, once again, is 15 to 35 feet, the PVC tree I put in here. And an interesting thing with this tree here is that September, October, November, December, and then also May, June, July, and August, Mille Lacs Lake is pretty much the same temperature from 15 to 35 feet down. And so if you think about the walleye in Mille Lacs Lake, that could have implications. But I especially wanted people to focus on these. This is a box plots again of temperature on the y-axis. I wanted people to focus on these summer ones and notice that there's very little temperature difference based on depth. This is another one of our inshore from Rocky Reef area. This is depths 2 to 10. Now, if you look over here, box plot temp in Celsius is on the y-axis. If you look over in January and February, you'll notice how this one here, 10, appears to be colder than 8. This is a coating error. So this one has to switch with that one. This one has to switch with that one. And so you got to switch to 8 and 10 around. But essentially what this is showing is that once again in September, October, May, June, and July, there's not much difference even between 2 and 10 feet. And even between 10 feet and on, but in the wintertime, there is definitely an apparent difference as you go deeper, so does the temperature go up. And I don't think that this 10-foot temperature is that much different than 15, but I'm gonna have to look into that further. So both life stages of Ogaa have temperature overlap during October, November, December, and May. Juveniles occupied significantly warmer water than adults from January to April. This may be due to the fact that juvenile Ogaa have a slightly higher optimal temperature than adults. And let's see here. And it may be juveniles need warmer water when it's cold to maximize their growth. Juvenile Ogaa lived in significantly deeper water throughout the experiment. Due to such differences in depth, it may be that the juvenile cannibalism window is short in duration as adults and juveniles typically are not at the same depth. It also may be that deeper water doesn't contain as many predators, so juveniles may feel safer in these areas. There was very little night and day differences between temperature, depth, and geographic location, and we do not know why that is. We also don't know if walleye movement increases or decreases during nighttime hours. The lack of night and day differences may also be due to quick diel movements around sunrise and sunset, which we need to look into further. Juveniles in January at night were significantly shallower than daytime. This could be due to feeding on zooplankton. Ice anglers, such as myself, have seen zooplankton at night swim up from the bottom on fish finders, and many times fish come in to feed on them. Adults in December at night were significantly shallower than daytime, and it could be that adults in December go shallower to find prey. Nighttime January had the closest temperature, depth, and geographic overlap between life stages. It is possible that juvenile cannibalism could be occurring during this time. It is also interesting as adults don't appear to move upward, but rather juveniles move shallower into the depth range that adults are occupying. Geographic overlap between life stages was limited throughout the year. Only September, October, and January had geographic overlap. It is unknown if these areas of geographic overlap change from year to year or are constant. Both juveniles and adults utilize southeast bays. These bays contain highly diverse habitats consisting of submergent and emergent vegetation, rocks, gravel, silt, and sand. There is also river input, which may be supplying nutrients, cold water, or having another ecological role, which is unknown. Juvenile Ogaa utilize the deep water in the middle of the lake potentially as a refuge or to feed. Overlap between the life stages occurred in rocky areas on the east side of the lake. The rocky and sandy areas located on the north end of Mille Lacs must be vital to adults as indicated by detection maps. Adult Ogaa most likely utilize these areas to reproduce and feed, and considering adults were concentrated during July and August on the north end, this may be where the squeeze is occurring. Lastly, the north end has many creeks and their ecological influences are unknown. Based on our Hobo Loggers, our water and temperature loggers, water temperatures get warmer by depth in the winter. There is little difference in depth and temperature in Mille Lacs Lake in the spring, summer, and fall. And it is possible water temperature may get too hot for walleye if they have nowhere to go in the summertime. Going forward, we are going to analyze data from 2019 until 2020. This includes Tullibee, northern pike, and yellow perch, which we tagged. We also want to determine if the squeeze is occurring during the warmest months. We are also going to compare fish and lake temperatures, and we have deployed light and temperature loggers in the lake even more, this time into rivers. We want to better quantify movement of fish in and out of Mille Lacs Lake, and we are currently doing so with receivers deployed and connecting streams. And we also want to further understand lake areas of Ogaa importance and why Ogaa use them. And with that, I'd like to thank everybody who made this experiment possible. And I'll take any questions that people may have at this time. Gichi Miigwech, great thanks.
Well, thank you, Carl. And this is really fascinating stuff. I really enjoyed the presentation. So thank you. At this point, we would normally clap for you if we were in person. So you'll have to accept my thanks on behalf of the folks listening in.
Of course, yeah.
I see we've got a pretty good number of folks online, and I'd encourage you, if you have questions for Carl, again, submit them through the Q&A function. You can just hover your mouse over the bottom of the Zoom screen here and type in your question, submit it, and we'll get it answered. We do have one question already, so I'll go to the audience questions first. So did you identify the sex of the adults? And if so, did you find a distribution difference between males and females like was found in West Virginia?
Well, we got to go back and right now look. I don't think I got to the sexing of the data just yet. Now I do know we had a little bit problem trying to determine what the sex of the adult was, just due to the fact that of surgery and our surgeons. But with that being said, we're still trying to work out those like I wouldn't say kinks, but those finer details of the study. Whereas how does age, how does sex have a play? So that is yet to go. So we have sexed them when we could, and we just have to process those results. So
Okay, thanks. Could you talked a little bit about predation and fishes that were identified as dead for one reason or another. Can you talk a little bit about, in addition to adult walleye, what else is eating walleye in this lake?
Yeah, definitely. So, our best evidence comes from the Blue Ribbon Panel, which was done by Miss DNR University of Minnesota back in 2014. Based on that one, they basically found that the main contributors of cannibalism of juvenile walleyes, well, first they found that was the main contributor, but there also a diet study that was linked up with that. Essentially what I'm saying is since 2014, what we know is that adult walleye are your primary consumers of the juvenile walleye. Second up is northern pike, typically smaller, I think it said. And then the third, maybe some smallies, but it was really minor, right? So I think the main consumers you're really looking at of those juvenile walleyes in this lake are your adult walleye primarily first, followed by your northern pike. So I would say those two are probably your main consumers.
And did that correspond then with the, you said there was an uptick in mortality rates around November. Is that consistent with what you expected?
Well, yeah, that juvenile mortality is what you're saying. I did not think they go down that fast in November. For some reason, they had a tough time getting past November. And if I can think about it right, I think they were shallow, but I don't know. But the bottom line is that there's something about November. I don't know if it's a high mortality month lake wide. I don't know. Maybe the juveniles just get stuck in the ice. I have no idea. But for some reason they had a tough time there in November surviving, and I don't know. We can't really comment because we didn't have predator tags on them whether they're eaten or not. So I'd be hesitant to comment and say that they all got eaten. We don't know, but it was something about November. Clearly, there are probably times of the year. So we got to look more into that mortality side. And we hope that future experiments we get into that predation, that mortality, a little bit more into that.
Great, thanks. We've got a question here. Did the fish hang out near streams during any specific times of the year? And if so, were there differences in that by age?
Well, we're still getting at that river receiver data. We don't have anything outside just a basic glance out of it. And there are definitely, I've seen fish go in and out of those streams, but mainly the bigger ones, and a lot of our smaller streams, almost all of them have come up short, to be honest, right now. But for the bigger, like the Rum River, the things, there may be bigger impacts in those area. But I'm definitely sure though, that the fish, I know some fish, I know the suckers go up the streams in the spring. I'm sure there is some movement, but we haven't yet to capture the serious movement. I think there's a lot of spawning habitat in Mille Lacs Lake for those walleyes, and I think a lot of them are choosing not to go into those streams really to make a major movement. Now, I don't know about the juveniles, but we haven't detected them in the streams. But that's just one theory I have, We're still looking into it too. We still got information to look into further, so.
Great, thanks. Next question. So you showed that there were some differences in their distributions vertically over the course of the year. And I know that you didn't recover those fish, so you don't have diets per se. But do you have any evidence from other lines of study or the Blue Ribbon Panel, other places that might suggest differences in diets or mechanistic reasons why they might be spending different times in those different vertical habitats?
There has to be. Just thinking from a biological standpoint, there has to be. Now thinking of why would they go in different fish habitats, I can only theorize, right? I don't know. At this point, we're not at the point we can conclude they're chasing a bait fish yet or something like that in our analysis, and I think there has to be every study shows difference in life cycle, gape limitation, different life cycles from benthos to that, but we still need to get a better idea. We need to get a better idea what they're eating by size. And I know the diet study tried to get into that, but it was only about a year and a half to a year. And so what we really need to know is what they're eating over like a 5-year period almost, and then have that data like correlate to like the ups and downs. But it's a very complex thing to get at. So I wish we knew a little bit more about what they were eating. But I suspect the juveniles are eating benthic organisms, and eventually I suspect they go eventually transition up to fish, right? Piscifery, yeah, piscifery.
Yeah, thank you. So, another question, based on the information that you've collected and your understanding for how the lake is functioning in general, what sorts of habitat conservation, protection, rehabilitation projects, would you recommend right now, or are we not at the point where we can really say much about that yet, and we need to do more study before we can be a little bit more prescriptive?
Yeah, I think we do. We do got to do a little bit more study to be to make a definitive conclusion on what exactly needs to be done. The only thing that really comes to my mind, and this is something that just in general, not based on a study, but it's shoreline development. And the more you develop a shoreline, it's not great for the lake. And you just from a general perspective of climate change and everything going on, more shade, more bugs, more cool water. So just a general, I suspect shoreline protection, is maybe needed. But with that being said, we still got to figure out, what can be done and how we can protect these areas.
Thanks. And I suppose as the Midwest Glacial Lakes Partnership Coordinator, I'm obligated to mention we have a Shoreline Living publication that encourages natural shorelines
Yeah.
and provides some of those alternative shorelines to use. So feel free to check that out. That's a good resource for promoting those things with shoreline property owners.
That's right. Yeah. Also, like stream remediation too. I would encourage. I had a tribal member tell me that there used to be 500 streams and like little creeks going to Mille Lacs, and now there's only like 18 to like 40. What did that have? On the ecological effect of the lake. And so also I think the streams, even if fish, walleye don't go into them, they still have a role to play in the bait fish or some kind of property. So I think also protecting, streams around these lakes is another big one. But we'll find out more of that based on our river receiver data. So
I'm definitely looking forward to that
yeah,
and staying tuned for that. We typically have an audience that ranges across the upper Midwest for the presentations, and I see a lot of folks from Minnesota on the list of participants, but I see a lot of folks from around the Midwest as well. So, if I'm a biologist or a manager on a lake outside of Mille Lacs, what lessons do you think you could take from this study, if any, elsewhere? How generalizable is the experience and the habitat and the system on Mille Lacs relative to other systems?
I think it's definitely a unique system, and you're dealing very large water, mesotrophic large water. So in a way, it is different from the standpoint of there's a lot of spawning habitat, right? There's a lot of spawning habitat. There's no shortage of that in other reservoirs in our systems. That is a big limiter, and so from that standpoint, and it's large, right? So it's more susceptible to those zebra mussels and spiny fleas than maybe a smaller system, but with that being said, I think there's nothing unique about Mille Lacs. The bottom line is what caused this. What most likely causes all the invasive change combined with the temperature change. Every lake almost, across the Midwest is going to undergo something similar to Mille Lacs, with the spiny water fleas, with the zebra mussels. And so in that sense, if you're near the Midwest, Wisconsin, Iowa, those areas, you can kind of imagine, what we're going through. But maybe if you're more south, such as they say West Virginia, I see down here, maybe more extreme, right? So the squeeze may be more extreme, and or the zebra mussels are effective invasive may just make it worse than it is up here. But a lot of Minnesota, Wisconsin, Michigan lakes are going through the exact, or will be going through the exact same thing we're going through, and that's just clarity change from invasives and climate change, and we're all going to have to learn how to cope with that. We're all going to be able to take similarities from one another's studies as we progress forward into the new era.
Yeah. For sure. Okay. See, I've got a few more questions for Carl, but I don't want
Feel free
to
to
be
ask.
the only one firing questions at him. So if again, I'll mention this is the last call for questions from folks in the audience. If you've got questions, please submit them through the Q&A function. And barring that, we'll wrap up shortly here. So let's see. I don't see anything else. So you mentioned that you've got some next steps from the perspective of research for multiple species on streams, and not being familiar with this system myself and the acoustic system that you had. Can you talk about the time frame over which this acoustic system is anticipated to be out and working in the lake? And is this a long-term project that you're planning to carry on for a while and look at multiple species, for a long time? Or how do you see this playing out over the next 5-10 years?
It's a good question. It's a really, really good question. Right now, it's been with us this whole time. You know what I mean? This was a 1-year study, but now we've expanded into Tullibee, Northern Pike, and for the last, I don't know, since 2018, to be a 3rd year now, we're going to be pulling up those receivers again. They're still out there currently, and so as long as there's fish tagged out there, it'll probably just be going for a while, until we finally figure out what we need to figure out and how to remediate them, but there's a lot of data. See, there's a lot of data we still got to analyze from the last 2 years. So I do see this could keep going long term because the data is very good. It's very unique, and it all just depends on as we go forward, what we do with the data, and if there's still a need for a study. We hope one day we can get the lake back up to where it needs to be, and then it'll be back on track. So I do foresee it going at least another 5 years, though, or a couple years more, definitely, for sure. So, and of course, we'll keep everybody updated with the results, and I think some of the most exciting results are yet to come. And we'll keep expanding species and learning more about the lake.
Great, thank you. Okay, well, seeing no other questions from the audience, I think we're in a good place. Again, Carl, I want to thank you for your presentation. Really fascinating stuff. I'm looking forward to hearing more about it as you move forward with additional research. So again, thank you on behalf of everybody in the audience and on behalf of the MGLP. A reminder to folks in the audience, we will be sending around an archive link to this presentation. So you'll have the video if you want to watch it again. You can watch it thousands of times if you'd like. And we'll be sending out Carl's information if you want to follow up with him with questions, any sort of thing like that. And again, encourage you to check in on the MGLP webinars page where you can view other webinars hosted by the MGLP. Thanks all and have a good day.
Bye.